Let's talk about the even problems on the precipitate ionic equation and net ionic equation worksheet. Keep in mind that you will have at your access the sheet that has the solubility rules. Be sure that you're actually utilizing this sheet to the best of its ability. You will also have not only this for the quiz, but you also have your periodic table. What I've noticed in class is that even though we've been doing stoichiometry for the last 2 or 3 months, it seems like when we present this as a type of problem, a lot of students have difficulty in balancing equations, remembering the fundamentals. Guys, you've learned a lot of information about how to write a balanced equation. Don't forget any of it. This is just another step, another way of working out these types of problems. So please don't overwhelm yourself. You're still doing the same thing. It's just some of the things that I'm seeing students do is just flat out stunning in some cases. So please remember the basics. Remember where your metals are on your periodic table. Remember where your non-metals are on your periodic table. Remember that metals have a positive charge, non-metals have a negative charge. Remember your 10 polyatomics. And even if you don't remember your 10 polyatomics, they're here on the sheet, and I wouldn't give you a polyatomic if it weren't on this sheet. So, and I've already had a few people take the quiz and they did really well, but then again, there's some that have taken the quiz and not done well because they simply have forgotten everything. So let's get right to the first problem. And again, I'm doing the evens. So question number 2 says that we have BiNO3, parentheses 3, which is bismuth 3 nitrate, is reacting with sodium hydroxide. So my recommendation is, even if I've given you the equation in this form, or I've given you the formulas, rewrite the whole thing. Also, write down the charges. Trust me, you might think that you're pressed for time. Your bismuth nitrate, so rewrite that, and your sodium hydroxide. And again, this is a double replacement reaction, which simply means that the metals are going to switch places. So the sodium is going to switch places with the bismuth, and the bismuth is going to switch places with the sodium, which means sodium is going to be with nitrate, bismuth is going to be with the hydroxide. Simple stuff, things that you've been doing all year. However, be sure that you keep the basics in mind when doing this, so that when you write the products on the right-hand side, don't worry about charges just yet. Write one representative of each. So write Bi with OH. Okay, don't worry about charges. The last thing you want to start doing is bringing over subscripts and things like that. The only time that you bring a subscript over from this side to the other is if it's a polyatomic. If you see parentheses, you never carry that parenthesis value or the parenthesis over, because again, that parenthesis is significant for this reaction or this compound. All right, so we have our bismuth with our hydroxide. Now we're going to write sodium with the nitrate. So again, sodium and nitrate. Just write one of each. One of each. Don't bring this parentheses 3 over. Once you've done that, write the charges down. You know that nitrate has a -1 charge. How do you know that? Because you looked on your sheet and you have it memorized. Nitrate, -1. That's one of your 10 polys. You should have that memorized. So you know nitrate's -1. There are 3 of these. Bismuth, there's only one bismuth here, so it has to have a +3 charge. So knowing that bismuth has a +3 charge, it should have a +3 charge on this side as well. Now I did have a few students look at the periodic table, and notice that bismuth, even though it's in the column that's the same as nitrogen, true, these do have a -3, -2, -1 charge. Very good. That's for non-metals. However, keeping in mind that when you look at this stair step, that stair step separates the non-metals from the metals. So when you look down here at the bismuth, it is below that stair step. So these values here are not negative 3 and 5, they're actually positive 3 and 5. So the bismuth does have a plus charge. Yes, even though it is in group 5A. So when you look on here, it does have a plus 3 charge. So knowing that it has a plus 3 charge, then what is the charge on hydroxide? You know hydroxide is negative 1. So what that means is, for to balance this one, we need 3 OHs. Okay, so notice there's no parentheses on the sodium hydroxide, but we do need a parentheses over here because again, when we look at the sodium has a plus 1 charge, and of course the hydroxide has a negative 1. That's why that's written the way that it is, plus 1, minus 1. Okay. Then over here, again, the sodium is still plus 1, nitrate negative 1. So we have to balance the charges first. Always balance the charges first. Then once you've had the charges balanced and the formulas are written correctly as is, in other words, all these have to equal 0 as an overall charge, then we balance the number of atoms. And when balancing the number of atoms, the best way to do this is keep the polyatomics together. So here on this side, we have 3 nitrates. How do I know? I have a NO3 and I have 3 on the outside. So if I want 3 nitrates here, I don't have 3. I only have 1 nitrate. Then I need to put a 3 in front because again, my charges are balanced. So 3 sodium nitrates is being represented here. So I have my 3 nitrates on both sides. I now have 3 sodium. So let's look over here. Here I only have 1 sodium. So I need to put a 3 there. By doing that, now that gives me 3 hydroxides. Here I have 3 hydroxides. Looking good. I have 1 bismuth, 1 bismuth. So there is the first step. Just like when we were doing stoichiometry, you still had to do this. In other words, write out the balanced equation. That's what all this involves, writing out the balanced equation. You had to do that. You've been doing that for many, many weeks now. All right, so now that we have all that, if you need to, well, I'm going to leave those charges on there. Let's leave the charges on there. I'm going to tell you everything that we start with, especially in honors chemistry, doesn't necessarily mean it will be in AP, but in honors chemistry, these are all soluble. So don't look on the chart to see who's forming a precipitate, because forming means arrow on this side. So we'll look to see who forms a precipitate on this side. So go to your table, okay, and then you ask yourself, okay, well let's start with the sodium nitrate. So sodium nitrate, so find nitrate on your table. There's nitrate, go across. Is sodium any positive ion? Yes. Soluble. Soluble means clear. In other words, it does not form a precipitate. It doesn't form any solids. Okay, so let's look at the other one. Bismuth hydroxide. So again, find hydroxide. Hydroxide's down here. Go across. Is bismuth an alkali ion or ammonium? In other words, is bismuth located in group 1A? Is bismuth located in group 1A? No. Bismuth is way over there. So here we don't have an alkali metal. Okay, so, whoops, go back to the table. So, no. We go to the next row. It says, is bismuth any other positive ion? Yes. It's not soluble. So what that means is we do have the formation of a precipitate. So, write PPT. Now that we know who our precipitate is, now we can write our ionic equation. Ionic equation is simply that. It is the equation representing all of the ions that we start with. So in this first container, okay, we have bismuth nitrate. In the second container, we have sodium hydroxide. And what we're going to do is we're going to take these 2 containers and we're going to pour them together. We're going to take these 2, actually let's move you over here. We're going to pour these 2 together into a third container. And as we pour the substance into here and the blue into here, then it's going to make that blue and black, they're all going to get together. And what we want to find out is, okay, when I take my bismuth nitrate and I take my sodium hydroxide, which are in separate containers initially, and they are soluble, when they are mixed together, is there going to be a precipitate form? So again, when you look at the reactants or the things that you start with, they are in two separate containers, and then we will mix them together. That's what the arrow represents, is a mixing process. And when these two mix together, we find out that, oh yeah, when bismuth finds hydroxide, it forms a solid or precipitate. When sodium finds nitrate, it's like, nope, nothing happens. And actually, since nothing happens, we'll give that an official title here in a few minutes. Okay, so let's write out our ionic equation. Writing out the ionic equation, what we're going to do is we're going to break this compound into ions. In other words, into metal ions and non-metal ions. So the bismuth, Bi, has a +3 charge. Write that. We have one bismuth with a +3 charge. Now again, that's one reason why we balance everything before we write the ionic equation. That way it becomes very easy. Then we're going to have 3 nitrates. So I'm going to have 3 NO3s with a -1 charge. Okay, I've taken my metal, there's my non-metal. Notice charges are listed here. Then I have 3 sodium ions. So I have 3 Na plus 1s. Okay, so again, taking my sodium, there's my metal. And I also have 3 hydroxides, 3 OH. Okay? So this is the left side of my equation. This is my left side where they all should be ions because again of my 2 solutions. Then I keep the PPT together. Keep the PPT together. So I have my bismuth hydroxide. That's the only thing that stays together. Once you circle it, it should look the same in all the equations from that point on the right side. And then to finish this off, I should have 3 sodiums over here as well. And I should have 3 nitrates over here as well. And notice that since I have 3 sodiums, and actually I'm running out of room here, but I'll put, whoops. I have 3 sodiums, 3 sodium ions, and 3 nitrate ions. Since I have 3 sodium, 3 nitrate, 3 sodium, 3 nitrate, these are considered spectator ions. In other words, they started off as sodium and nitrate ions in 2 separate containers, and they finish as 3 sodium and 3 nitrate ions together because they're not reacting or forming anything new. So there is my ionic equation. I did write it a little too big. I apologize for that. I won't do that on the next ones. So that's the ionic equation. The net ionic equation is taking my things that I have from the ionic equation and saying, okay, well, who or what forms the precipitate? So we know that we have, and it's probably not a bad idea, let's write who forms the precipitate first. So I have BiOH3, that is my PPT. What makes up BiOH3? Well, bismuth ions and 3 hydroxide ions. And this is my net equation. Okay. So there is your answer to number 2. So your equation to get everything balanced and charged and everything in place, breaking it down into the ions, starting off with my 2 solutions of my bismuth nitrate and my sodium hydroxide, allowing those to mix. As a result of those mixing, bismuth hydroxide is formed, and then the sodium and the nitrate don't do anything. They are spectator ions. So that's why spectators never appear in the net equation. All right, let's look at number 4. Now, since this is in word form, now we got to work a little harder here. All right, but that's okay. You like working. So iron 2 nitrate. Now again, this Roman numeral 2 here represents the charge on the metal. So it doesn't mean there's two irons. There might be two, but it doesn't mean that there are two. So the iron, and let's go ahead and put the charge on there just to make everybody seem happy. And nitrate is NO3. We'll come back to that here in a second. And let's see here, we also have ammonium sulfide. Now notice that it ends in IUM, so that means that we have a polyatomic in this case, because you know ammonium's NH4. So NH4, and we'll get the charge here in a second. Sulfide ends in IDE, so that's an S. Okay. So while we're here, let's go ahead and balance our charges here. So we know that nitrate is a -1 charge, so that means that we need two of those. So if I have two nitrates, it's a poly, so parenthesize that. And then coming over here to the charges, ammonium. And again, you know your 10 polyatomics, but if you just, for whatever reason, have forgotten, this table can bail you out. Hopefully it won't bail you out, but it can. So the ammonium has a +1 charge. Sulfur, again on your periodic table, is over here. So sulfur is in group 6A. So again, that -3, -2, -1, and it does have a -2 charge. So the sulfur is a -2. So the iron to nitrate is balanced, but our ammonium, we need two of those. So that means that we're going to put ammonium in parentheses and then the 2 on the outside of the parentheses. Okay, so we have our reactants. We're ready to go. So now, again, we have our two containers, and we're gonna pour them together and make a new solution. So on the product side, we're going to have iron getting with sulfur. Again, if it's listed and it has a positive charge, that is a metal. If it's listed and it has a negative charge, we're going to treat that as a non-metal. So don't freak out and go, oh, who do we write first? Always write the metal first. Always write the metal first. So iron with sulfur. So FeS. We'll come back and do the charges. So I'm just writing one of each. So iron and sulfur. And then we have ammonium. That's the plus charge. That's why I'm looking at that one first. So ammonium, NH4, and nitrate, NO3. Okay. So let's go in, put the charges back on there. So iron's still +2, sulfur's still -2, ammonium's still a +1, nitrate's still a -1. Notice I didn't bring any of the parentheses over. That would look really bad if I had two sets of parentheses here and they both had the same subscript. So that's why you always write one and then check the charges. If you need more than one, then you show it. Okay. All right, so we have our charges balanced. So now let's balance the number of atoms. Well, the iron, actually, let's start with somebody that's in the parentheses. So the nitrate, we have two of those. I only have one, so I need two there. Again, don't get creative and put parentheses there and say, oh yeah, I put two there. No, once the charges are balanced, we go with coefficients. So now I've got two nitrates, two ammoniums. I'm balanced. Okay. Again, probably the hardest part of this whole problem is just balancing and getting the products written out correctly. All right, so let's look for a precipitate or a not soluble. So let's look at the ammonium nitrate first. So you find your nitrate, which is right up here near the top of the table. Nitrate, any positive ion. Ammonium is any positive ion. So that means that, yep, that one's soluble. And what was the other one? Iron sulfide. So find your sulfide, which is S with a -2 charge. So we come across is, what was it again? I'm sorry, I'm drawing a blank. Iron. So is iron an alkali ion or ammonium? In other words, is it in group 1A? Is iron over here? No, iron's right here in the middle. Okay. Is iron listed here as beryllium, magnesium, calcium, strontium, barium, radium? It is not. So we go to the third row. Is it any other positive ion? Yes, it is. Not soluble. So there is our PPT. So identify it as your PPT. There you go. Okay. So now you've got the first step completed. Now we write the ionic equation. Okay. All right. So now I'm going to use a little bit more room over here. So I'm going to take my iron plus 2, because I only have one iron, and I'm going to add that to my 2 nitrates. Again, the parentheses tells me that I have 2 nitrates, so 2 NO3s with a -1 charge. Notice that we don't write parentheses as ions. These are individual nitrate ions in solution. And then I have 2 ammonium ions, so 2 with NH4. Also I have 1 sulfur with a, I have 1 sulfur with a -2 charge. That looks a little better, that's a little smaller. Okay? Then we arrow. Keep your PPT together. So iron sulfide, I'm not going to split that guy apart because it has come together and formed a solid. And then we have 2 ammoniums. So NH4 with a +1 charge. And we also have 2 nitrates. Okay. All right, so again, we have our iron sulfide, which is our PPT. Notice how that is still intact together. Our ammoniums are nitrates. These are spectators. These guys here are spectators. They don't change. They're the same on this side as that side. So when you write the net ionic equation, the net, again, my advice, write your PPT first. So you have your iron sulfide. And then what makes up your iron sulfide? Well, iron ions, Fe with a +2 charge, and your sulfur ions. Okay? Again, be sure you're writing charges on the ions. You don't need to write charges on your compound. If you wrote the charges above, that's okay, but don't put a plus sign between the atoms within your PPT. All right, let's look at the next one. Number 6, we have sodium iodide and silver nitrate. So again, write out your balanced equation. Let's do that first. So we have NaI and silver nitrate. Okay. Let's go ahead and put some charges on that. Sodium, group 1A, +1. Iodine, group 7A, -1. Silver is right there with a +1 charge. So +1, and nitrate, which we've been talking about a lot, is -1. So these are all 1 charges, either plus or minus, which is very nice. You gotta like that. Okay. On the product side, you're gonna have your silver get with the iodine, and your sodium with the nitrate. So let's go sodium nitrate and silver iodide. Again, I don't think we need to write the charges since they're all plus and minus ones, but please do check carefully to make sure you have your metal written first and you have a metal with a non-metal. Make sure you have your metal written first and you have a metal with a non-metal. Okay, so all these are balanced. So let's check to see who is our PPT. So sodium nitrate. So find your nitrate. Any positive ion, soluble. All nitrates are soluble. Remember that. That's a quickie. And then silver iodide, so find your iodide. Even though it's on the bottom, we still start on the top row. So iodide, come across, oh, there's silver right there, not soluble. So that means that we're forming a PPT. So there is your PPT. Okay? So let's write our ionic equation because everybody's balanced. They're all plus and minus ones. So the ionic equation, this where we have Na +1 plus iodine -1 plus silver +1 and nitrate -1 forms our sodium +1, our nitrate 1, or I'm sorry, -1. And last but not least, little silver iodide, which is our PPT. We keep together, okay? So charges are listed, yes, they are ones, plus ones and minus ones, still indicated, okay? And then the net equation is what makes up our precipitate, which in this case is silver iodide. So that means that we need some. And if you write the iodine before the silver, that's okay. Again, the plus sign just means and. So if you do this, please don't write the iodine first there. All right. If you are like, oh, I just don't like the way that looks, then go ahead and flip it on here because there's a plus sign. What we can't do is we can't flip it here because there is no plus sign. There is a convention with which you have to follow. All right, so that one was pretty easy, pretty straightforward, I would hope. That's an easy one. All right, the last one. Write an equation for the reaction of solutions of sodium hydroxide and nitric acid. Since we haven't talked about acids and bases yet, I will give you the acids. Now the bases, you can still write that out. That actually is a base, but there's no special naming system with bases as there is with acids. So let's write it out. So sodium hydroxide is NaOH. We'll come back and balance these in a second. And the acid, if the formula is given to you, it is correct. So you don't have to worry about messing around with that or finding charges, but if you need to find charges, that's fine. On the product side, we're going to have, and keep in mind, a hydrogen is a metal, and it will be switching places. So we're going to put the hydrogen with the hydroxide, sodium with the nitrate. So we'll do that. So, and okay, let me do charges. So sodium's +1, hydroxide's -1, hydrogen's +1, nitrate is -1. You probably already knew that. All right, so switching places. Let's put the sodium with the nitrate. And now we're putting the hydrogen with the hydroxide. Always write the metal first. So hydrogen with hydroxide. And if you go and look, let's move this guy out of the way. So if you go and look on your table and you say, okay, well, I've got, what was it again? Darn it. We have sodium nitrate. Well, we know that. The nitrate isn't going to form anything, so we know that's soluble. But then if you go to your table and you say, well, okay, well, there's hydroxide. If I look at alkali ions, hydrogen technically is an alkali ion. It's in group 1A. It's soluble. Don't automatically go, oh, there's no reaction. What has happened here is we've taken some pretty nasty hydroxide ions and some pretty nasty hydrogen ions, which can do some damage, and we've neutralized them by making water. So we do have a reaction here. It's not a PPT. Notice I'm not writing PPT. If you feel like you need to write something, you can put a little L there, which represents liquid, but this is just a reaction. It's a neutralization reaction where you're taking hydroxide and hydrogen and making something. These are not remaining in solution. These are forming a brand new substance. By definition, that is a reaction. Okay, so based on this information, again, we have everything balanced. Now let's write out our ionic equation. So the ionic equation would look like this, where you have your sodium ion plus your hydroxide ion plus your hydrogen ion plus your nitrate ion. Again, breaking these guys down. And you're forming sodium ions. They don't do anything. Nitrate ions also don't do anything. And water. So we're making water. We're making something. Okay? So this is a neutralization reaction. By definition, you are taking hydroxide and hydrogen and making water. Also, if you're not comfortable with writing water as HOH, you may write it as H2O, but whatever you do, don't write it as OHH. Don't do that. Please don't do that. And then the last step, write the net. So what makes water? That's right, hydroxide ions and hydrogen ions.